Hello and welcome to this talk about operating Korifi for beginners. In this talk we are going to look into Cloud Foundry based on Kubernetes in its latest edition named Korifi. Few words about myself. I'm Julian Fischer, CEO of a company called K8s, and this company is dedicated to building and operating large-scale application development platforms based on contemporary technologies such as Cloud Foundry, Kubernetes, and many more. So first of all, in this talk, we are going to look into the idea of how to operate Korifi from a particular perspective. So a few words about the context. First of all, the goal is, eventually be able to manage a lot of Korifi clusters. It's a short talk and therefore we're only going to touch the surface, but the ultimate vision is not to run one single Korifi cluster, but a lot of them. We're talking about dozens or even hundreds of those clusters in a platform environment. So in general, the approach on how to engage with operating Korifi is something we'll look into. In particular, the question is how do you lifecycle manage Korifi, and what does lifecycle management actually mean? I'd say in very simple terms, lifecycle management means whatever the sysop would do or the devop would do operating Korifi manually. This could be, for example, creating a Korifi cluster, deleting a Korifi cluster, making upgrades, performing backups and restoring them in the case of an incident, monitoring its availability, monitoring its capacity, and scaling it up, scaling it down, for example, to host more apps or to adapt a Korifi cluster when apps have been removed from it. And also, keeping Korifi itself up to date by, upgrading to newer patch level versions, minor versions, or even major version upgrades should be covered. So basically, anything that you want to do with your Korifi clusters or anything the eventual owners of Korifi clusters want to do with their Korifi installations is what the lifecycle will cover. Now, it is pretty clear you can't do that in just a single attempt. So we have to approach the automation of the lifecycle step by step. And in this talk, we are looking at the operations in particular, and we look into what are the things that we can do for beginners. So if you are new to operating Kubernetes workloads, if you are new to operating Korifi in particular, a good first step is to look into the dependencies of the workload you want to operate. So in this case, we want to operate Korifi. And the first question pops up is, what do we have to install on the Kubernetes cluster before we can install Korifi? The Korifi documentation will give us advice about this, and by creating a dependency graph, you'd be looking at something like this. So there's a Kubernetes cluster which is required, of course. We need a cert manager, for helping with certificate rotation and all those things you need to deal when handling with certificates. Your applications are likely to have certificate dependencies, and they need to be managed somehow. So Kpack is a part of Korifi that depends on Paketo build packs per default, which is the subsystem that takes your source code and turns them into container images. We have Contour, which is an ingress, which means that part of a Kubernetes cluster that allows incoming connections, HTTP connections from outside of the Kubernetes cluster and map it to services or other endpoints within the Kubernetes cluster. There's a metric server, and optionally you can also add a service binding controller which will extend your Cloud Foundry with that ability to create service instances in where it also talks to a service broker, in contrast to the user-defined service where you basically all you do is store credentials and then be able to bind those fixed credentials to applications, which has certain drawbacks, because if you want to bind multiple applications, you'd basically have to create multiple user-defined services, or you'd be reusing a particular set of credentials, which may not be the best choice if security is important to you. So if you look into those relatively high-level use cases we've looked at a few slides ago, for example, backups, restore, creating a cluster, upgrading a cluster, monitoring it, there is a natural order to some extent, because the first use cases you possibly want to do is create a Korifi cluster in the first place. But then, that's first day operations. We also want to look into, day two operations. So if you think about what are the use cases you really want to have, at a particular milestone, you will have to decide which one matters to you more. And also, to what extent do you want to implement that particular use case? So in this talk, for example, we pick the creation of a Korifi cluster from scratch, and we'll look into how to create backups of a Korifi cluster. So the talk is short, we cannot cover all of it, but at least we can provide you with an idea on how to approach Korifi operations methodologically. All right, so how to manage Korifi? The first choice you'd have to make is, do you want to use a Helm chart, or do you want to go with plain YAML? And there are particular advantages and disadvantages to each approach. If you're not very familiar with Kubernetes, if you're not very familiar with Korifi, maybe going with Helm would be the right choice for you, as a lot of complexity is hidden by using Helm charts. However, if you're a more advanced user, well, then you possibly don't need my advice at this point, but then you'd naturally go for either a YAML based operational approach, or you'd start customizing the Helm chart to your particular desires and requirements. So for example, that those configuration options that you need are actually exposed via Helm chart. So to keep it simple, if you wanna have a simple solution and less flexibility is okay for you, you go with Helm charts. If you want to do more than that, you may have to customize the Helm chart, or you go with the YAML based approach, where you either create your own automation, let's say an operator, or you use a CI/CD tooling in order, with a GitOps based approach, to manage your Kubernetes based Korifi. When you look at operating a large set of Korifi clusters, that direct CI/CD approach with GitOps may not be the best choice, because if you want to unify operations, you may want to have a better abstraction. It gives you more fine-grained control over the way particular upgrade steps are carried out, and distributing those steps based on CI/CD may not be the most effective approach. So if you look into installing Korifi using Helm, it's pretty straightforward. You have this Helm install command that receives a lot of settings. So the more settings the Helm chart supports, the longer this list will get. No worries, you'll have time to dig through documentation of Korifi and understand those individual flags yourself. As you can see, there are also shell scripts, so you'd have to set those values before executing that command. It's all in the documentation. So that's basically straightforward. Helm then, does the magic for you. It talks to the Kubernetes API and applies all the resources that you will have to create in order to get your Korifi running. However, at this point, when you install, and execute that command, you already have to have the dependencies installed. And that's where lifecycle management becomes a bit more tricky. Because it's not only enough to install Korifi, you also have to maintain, those dependencies. And it is very likely that Korifi makes certain assumptions for each version of Korifi. There are assumptions about the versions or range of supported versions within the dependencies, and you need to manage them in a particular way so that the contracts between Korifi and the dependencies are met. And this is already part of the complexity of running distributed workloads and also running workloads on top of Kubernetes based on Kubernetes extensions. Dependency management is hard, and lifecycle management is also hard. So here we have Helm. Helm also helps you with providing upgrades. So in the first slide, for example, we've used Korifi version 0.0, and using that command we would upgrade to 0.7.1. So that's a patch level upgrade based on semantic versioning. One could expect that upgrade should actually proceed and without bigger issues. Now, if you doubt that, it would be advisable to have a backup so that if things go wrong, you can somehow roll back to an older or to the old version and have a continued service of Korifi as much as possible. And we come back to that backup question later. But at this point, you already get that if you perform upgrades, beyond patch levels, minor, in particular major version upgrades, you may want to have a backup and restore plan in place if things go south, that the service interruption is kept to a minimum. And that's what I meant with pointing out that certain use cases have a natural order. So of course you can implement the install use case, which is already handled here for us by using the Helm chart. And conveniently, the upgrade functionality is also there. But without a plan on how to make a backup and possibly how to monitor the cluster to see whether there's actually something wrong with the cluster during or after the upgrade, it would be kind of keen to execute that statement, without having that fallback of monitoring and backup functionality. So, as mentioned earlier, the installation of Korifi requires the installation of certain dependencies, and managing those dependencies is already a prerequisite to installing Korifi in the first place, because the Helm chart won't work if you don't have the dependencies installed. So again, there's this natural order of things that you'd have to, just accept, is you need to deal with the dependencies first. So again, you'd be, in the situation to decide how do you install those dependencies. If you want to maintain a certain style of automation throughout your entire platform. For example, you want to use Helm all over the place because that's your central assumption on how to automate things. You'd have to create Helm charts for all the dependencies unless they're already there. Now, Helm is a wonderful tool, but not every component out there relies on Helm charts. So if it could be the case that you also have to go with a mixed scenario where you use Helm for certain workloads or dependencies, and you'd have to use YAML or some other lifecycle manager for other parts of your dependency graph. Now, as mentioned earlier, having a backup for a Kubernetes cluster with Korifi when you want to perform a complicated lifecycle management operation such as a major version upgrade to Korifi or to one of its dependencies is smart to do. So then the question rises, well, how do you back up Korifi? Which boils down to how to back up a Kubernetes cluster, because if you look into Korifi's design, you'd recognize that the authors of Korifi have expressed Korifi as custom resource definitions, and the custom resources created according to those custom resource definitions are stored in Kubernetes, in the Kubernetes etcd. So the state of Korifi is not stored in a Postgres database as with classic Cloud Foundry. Instead, the underlying etcd of the Kubernetes cluster is being used. So as long as you have solved the backup challenge for your Kubernetes cluster, you should be fine with Korifi as well, at least in theory. So the question is, how do you do backups of a Kubernetes cluster? And there are surely many ways to do that. Coming from that ecosystem, from the Cloud Foundry ecosystem, you may want to have a look into Velero. It's an open source project. It stores and it allows you to create a backup of the Kubernetes etcd and restore it. It can be installed using a Helm chart. It allows you to create it allows you to create backup schedules where backups are created for you periodically, which somehow looks like this. So the specification of a schedule is pretty straightforward. It uses that cron tab notation, just like the cron tab, the cron job kind within Kubernetes itself. You can also do lifecycle operations on Velero using Helm. Here, for example, you would apply the schedule you've created above using the Helm upgrade command. Of course, you can also create manual backups, which is in particular of interest if you do want to perform a larger upgrade. So in this case, you could just use the Velero CLI to create a backup on demand. Of course, it also, a backup is only as useful as the ability to restore the backup. So restoring the backup is straightforward, also uses the Velero CLI, and that's how you do it. All right, so there's much more to say about Korifi operations, but I hope the introduction helped you to figure out, how to do it methodologically. You create a dependency tree. You look at each dependency. You look, into the documentation. What's the lifecycle management tool offered by the maintainers of that tool? So in case of Korifi and in case of Velero, it has been Helm. If you look back into the dependency chart, you will see that you also have to look for a way to manage cert manager and those other components. But in general, that's the way how you do it. Next, on the critical path for most of the major version upgrade use cases, for most of the more significant changes you would like to apply to Korifi, whether this is a substantial configuration change or whether this is a version upgrade, you want to have implemented a backup and restore use case, and we just drafted how a research for such a use case could look like by looking into Valero, seeing that Valero basically allows creating and restoring backups as that's what we want. So it would be a valid choice to pursue operations, with the assumption that Valero will be good for backups. So Korifi operations at this moment is absolutely something you can do. It will require some love. Hopefully in the future, there will be more lifecycle management tools, and there will be that standard, out there that everybody uses, so that maintaining complicated composite workloads as Korifi will be simpler. But at this point, it's already feasible to use Korifi. We use it in smaller scenarios or where Kubernetes native workloads are necessary. For example, where the infrastructure abstraction layer is Kubernetes, for example, let's say in offsite regions or in small micro regions, let's say a power plant or a retail store where there's a physical compliant appliance set of servers running Kubernetes, and your infrastructure abstraction is Kubernetes. So hopefully you've learned something for today. If you have questions, feel free to reach out on Twitter, for example. Hope you enjoyed the talk, and see you next time. Bye-bye.